Good morning or afternoon, classes. This is your lesson on 2.8. We'll be solving inequalities in one variable. By the end of this lesson, you should be able to solve inequalities involving polynomials and rational functions by using both algebraic and graphical techniques. So at this point, you should have your notebooks out, your graphing calculators out, and be ready to write down the notes that I go through here today. If you need to at any time, pause this video so that you can make sure that you understand what's going on, talk through problems where there's questions, and also have time to answer questions before I reveal answers. We'll start off with an example problem, or we'll start off with our definition of a polynomial inequality. A polynomial inequality can take the form of a function being greater than 0, greater than or equal to 0, less than 0, less than or equal to 0, or just not equal to 0, where f of x is a polynomial. To solve f of x is greater than 0 is to find the values of x that make f of x positive. In other words, if we're asking to solve f of x is greater than 0, we're basically asking for what x values is the graph above the x-axis. If we're asked to solve f of x is less than 0, we're just asking what x values will give you a graph that's below the x-axis. So now, for our first example, we want to find where a polynomial is 0, positive, or negative. The polynomial function that we're talking about is f of x equals x plus 3 times x minus 4 squared. We want to determine the real number of values of x that cause f of x to be 0, positive, and negative. So kind of three problems within one. Well, quite quickly, as you're writing this problem down, if you haven't already, it's quite easy to find where the zeros are since this polynomial is already factored. You know from this factor, x plus 3, that one of the zeros would be negative 3. And from the factor x minus 4, you know that one of the zeros would be 4. What we're going to do now is we're going to use a sign chart to find the intervals where f of x is greater than 0 and f of x is less than 0. This is a technique that I want you to use for all these problems that you're not solving graphically. What you're going to do is you're going to set up a chart. Basically, it's a number line where the only numbers on the number line in this case are going to be the numbers of where your zeros are. See, what you should realize here is we put the zeros on the number line, and then if you think of it graphically, that's going to be your x-intercepts. Well, on either side of your zeros, you're going to have values that are either positive or negative, and throughout the entire span of each zero, like throughout this entire area, all the values will be the same. What I mean by the same is they'll either be positive or negative. All the values here could also be either positive or negative, because as you know, at any one zero, you could have a bounce or you could go through the x-axis. So that's what we're going to determine right now. It's quite easy to do that because all you need to do is test some point within that range. So what we do is we take our polynomial function right here, and what we'll do is we'll plug in a value in for the x's and just say whether the answer is going to be positive or negative. So what I mean by that is if I plug in a really big negative number in for x, what are each of these values going to be? Well, let's say I plugged in negative 10. Negative 10 plus 3, well, that's going to be negative 7, so it's a negative number. Negative 10 minus 4, that's negative 14. I just need to know, is it going to be a negative number? Because, so that's going to be negative 14. But remember, you are going to square that. I'll show you how that comes into play right here in this little chart. We have a negative times a negative squared. Well, what's a negative squared? It's a positive. So a negative times a positive, what is that going to equal? A negative. So that means to the left of negative 3, my graph is going to be below the x-axis, so I'm going to get negative values back out. Do the same thing between negative 3 and 4. Maybe you want to plug in 0, since that's between negative 3 and 4. If I plug in 0 here, I'm going to get a positive number. If I plug in 0 here, I'm going to get a negative number. But remember, again, what you're going to do is you're going to square that negative because of its multiplicity. Well, positive times a negative squared is going to be a positive. And then finally, do the last thing, take a really big positive number. Both of those will end up positive, giving you a positive answer. And so what can you tell from this? Well, you can tell that the graph is going to start off negative. Once it gets to negative 3, it's going to go through the x-axis. You'll have positive answers. When it gets to 4, you're going to bounce off the x-axis and come back up. This sign chart is going to help you to realize if it should be positive or negative in each spot. So then the next question was, determine the real number values of x for which the function will be positive. Well, you know it'll be positive for anything greater than negative 3. What we can't do, though, it's for everything greater than negative 3, but you got to remember that what is 4? It's a 0, so we do need to separate on our interval. We do need to take out that 4 and not include it because it's not positive. It's 0. And then, likewise, part C asks, when is it negative? Well, how do you write the interval for this portion of your number line? You'd say from negative infinity to negative 3. We'll move on to the next example. Same type of question, only now we have x plus 3 times x minus 5 over 5x minus 2. So we're going to try to determine the real number values of x that cause r of x to be 0, undefined, positive, and negative. So the first part should be easy. When will this function be 0? It'll be 0 when you set the numerator equal to 0. When you set the numerator equal to 0, you basically set each factor equal to 0 and solve. I'll give you a chance to write that down. Don't leave, that wasn't your bell. That was just a bell that went off when I was recording this. Nice try. So, you know the zeros would be negative 3 and 5. When is the graph going to be undefined? When the denominator is set equal to 0. Let me just grab this so you can still see it when I scroll up. Pretty nifty trick I just did there, wasn't it? So the second question was, when is the function going to be undefined? When the denominator is equal to 0. So 5x minus 2, when does that equal 0? Give you a chance to answer it there. X equals 2/5. So then we're asked, when is it positive and when is it negative? Well, I'd like you to make your sign chart again. So what are you going to include on your sign chart this time? The zero, where it's 0 and where it's undefined. So again, you're going to use this function and make your sign chart accordingly. So if I take a really large negative number, plug it in for each of the x's, I'm going to plug in a really large negative number here, a really large negative number here, a really large negative number here. I just want to know what the sign of each one of those is going to be. If I do that, well, then I should be able to tell if it's going to be positive or negative. It's just a quick way. Shouldn't take hardly any time at all to do. Well, negative times a negative divided by a negative, what does it equal? Class, what does it equal? Good, negative. Do it again for these, between negative 3 and 2/5. Well, 0 is between there, so go ahead and make your sign chart up. Your teacher can pause at this point and let you fill out this chart. This is what your sign chart should have looked like if your substitute paused. And then very quickly, this would be positive, this would be negative, this would be positive. From this chart, you then should be able to tell me the intervals in which this function is positive and the intervals in which it is negative. Your teacher can pause again to let you write that down. So there was a little error on there. I had to fix quick here. So this would be the answers you should have gotten. R of x is positive if x is between negative 3 and 2/5, or x is greater than 5. R of x is negative if x is less than negative 3. Oops, that's where that problem came in. Timeout. Just get rid of that. Is negative if x is less than negative 3 or between negative 2/5 and 5. So we'll move on to the next problem. Here's an example that you can solve where you can solve your polynomial inequality graphically. Give you a second to write it down. The first thing you're going to do is you're going to rewrite the inequality so that there's a 0 on the right side. To do that, you just simply subtract or add the different terms over to the left side. Now, graph the polynomial that you have. Graph y equals x cubed minus 6x squared plus 8x minus 2. And then I want you to find the zeros. Your sub can, or you can, pause this right now and give everybody a chance to find those graphically. You should have found that your graph looks something like this. So now you should have solved and found each of the zeros. And hopefully you found that those zeros were approximately 0.32, 1.46, 4.21. So then the solution that you want is going to be, since it says, the polynomial says less than or equal to 0, you want to include the zeros and then anything below the x-axis. So your solution will be any values from negative infinity to 0.32, approximately 0.32, and then any values from 1.46 to approximately 4.21. All I did was I took the values that were below the x-axis and including the y, or the x-intercepts. Everything I highlighted there. Since it said less than or equal to 0, that's what I wanted. If it would have said greater than 0, if it would have asked for everything greater than 0, I would have took what was above the x-axis. So another example here, when you have a rational function, you're going to do the same type of thing. Only you're not only going to find the zeros and put those in your sign chart, you're going to also find the values that would make the function undefined. What you need to, and then what I do on my sign chart is right above the numbers that I plotted, I put whether it was a 0 or it was undefined. So again, where are the zeros? You set the numerator equal to 0 and solve. So when you set that equal to 0, you get -1. When you set the denominator equal to 0, that's when you get your undefined portions of the graph. Well, x plus 3 equals 0, then -3 is going to be where it's undefined. X minus 1 set equal to 0, then 1 is where it's going to be undefined. Oh, it looks like I got to adjust something here. Just one second. I just had to adjust the 0 and undefined on this chart. We're backwards. So I had to switch that. So we know where it's undefined. We know where it's 0, and now you do the same type of thing. Plug in number less than -3 into each of the 3 spots on your rational function to get whether each part is negative or positive. From there, you can tell everything less than -3 is going to be negative. You go ahead and finish the chart. Your substitute can pause it at this point, or you can pause it if you're doing this at home. So your chart should be done. Should look something like this. Get a positive value between -3 and -1, negative between -1 and 1, and positive everything greater than 1. So where is the chart going to be positive and where is it going to be negative? That's the next question. Go ahead and write that down. Your sub can pause it if you need more time, or you can if you're doing this at home. And those are the answers you should have. It's positive between -3 and -1, and from 1 to infinity. Negative from -infinity to -3, and from -1 to 1. Got one more problem here left, just to give you an example. If you have an inequality involving a radical, you do the same type of thing. Where is this function going to be 0? Well, it's going to be 0 if you plug in, oops, if you plug in a 2 into this factor, you'd get a 0. If you plug in a -1 into this factor, you'd get a 0. Now you also have to consider that you cannot plug in anything less than -1. That's why down here on my graph, I have undefined written in right away for everything less than -1. So that just leaves 2 portions left. I've already revealed the answers for you. You do the work the same way. Plug in a value between -1 and 2 for each portion, or each factor, if you will, and then plug in a value greater than 2 to tell whether it's positive or negative. That's it for the lesson. Work on your homework. This is the last bit of information for Chapter 2. Make sure you look at the board or look online to see the schedule for the week. Have a great day.